Hi everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. For this episode, our lesson is properties of a sector. In the previous episode, we already studied sector of a circle and I explained that sector is part of a circle. For this episode, I will be discussing the two properties of a sector. Okay, let's start. We have here a circle, and in this circle, there are four sectors. Okay, this is our first sector, second sector, third sector, and this is the fourth sector. These four sectors have the same center, and all the radius are equal. Obviously, sector 1 is the largest, sector 2 is the smallest. But what makes sector 1 the largest? What makes sector 2 the smallest? If you're going to take a look at this one properly, the central angle of sector 1 is the largest among the other central angles. The arc of sector 1 is also the largest, and the area of sector 1 is also the largest. Okay, now take a look at sector 2. The central angle is the smallest central angle among the other angles. This arc is also the smallest, and the area is also the smallest among the other areas. So it means the larger the central angle, the larger the arc, the larger the area. The smaller the central angle, the smaller the arc, the smaller the area. That is the first property of a sector. Okay, what about if the central angles are the same or equal? Take a look at this circle. Okay, this angle is right angle. So that means this central angle is 45 degrees. This is also 45 degrees, and other central angles are 45 degrees. This arc is equal to this arc, and the rest of the arcs. The area of this sector is just equal to the area of this sector, equal to this area of this sector, and the rest of the sectors. So it means if the central angles are equal, then the arcs and the areas are also equal. Okay, in summary, for the first property of a sector, okay, if the central angles are equal, then the length of the arcs, the length of the chords, and the area of the sectors are equal. Conversely, if the length of the arcs are the same, then the length of the chords are the same, or the areas of the sectors are the same. Then the measures of the central angles are equal. Okay, moving on. Let's go now to the second property of a sector. And this is about the relationship between the measure of the central angle and the length of the arc, the chord, and the area of the sector. Okay, take a look at this figure. We will compare the relationship between the measure of the central angle and the length of the arc, the length of the area of the sector, and the length of the chord. Okay, let's start with the relationship between the central angle and the length of the arc. Okay, if this is my central angle, then this is the arc of this central angle. If I double my central angle, then the arc also doubles. If I triple, then arc also triples. Okay, 4 times the central angle, then arc is also 4 times. So, central angle and the length of the arc are directly proportional. So if I increase the central angle 2 times, then arc also increase 2 times. If I increase 3 times, then it follows. Okay, what about the relationship between the measure of the central angle and the area of the sector? Okay, so if this is my central angle, so this is the area of this sector. If I increase or if I double my central angle, then the area also doubles. If I triple, then it follows triple also. 4 times, then the area is also 4 times. So it's the same in number 1. So the relationship between the central angle and the area of the sector is direct proportional. So if I increase 2 times, then the area also increased 2 times. 3 times, then the area also increased 3 times. So it follows direct proportion. Okay, this time, what about central angle and the length of the chord? Okay, if this is my central angle, then the chord of this central angle is this line. Take note, chord is a straight line. It's a line segment, and line segment is a straight line. So from this point to this point. So this is the chord of the central angle. If I double my central angle, so I include this part. So this is now my sector. Okay, the chord is from this point up to this point. Chord will not be this line. Chord is from this point up to this point. Okay, I doubled my central angle. The chord also increases, but it doesn't mean that it's also doubled. Okay, so the relationship is proportion, but not direct. So it also increased, but it's not 2 times, or it's not really 2 times. Okay, what about if I increase my central angle 3 times? So this is now, okay, this is now my sector. So if this is my central angle, then my chord is from this point up to this point. It's not this line. So this is not our chord, but this straight line. So I increased my central angle 3 times. Chord also increases, but it's not 3 times. So the relationship is proportion, but it's not direct. Okay, so let's answer now this concept check question. First question is, how many times longer is the length of arc AE compared to arc AB? So this is our circle. So arc AE is this arc. AB is this arc. It's asking for how many times longer is arc AE to arc AB. These dots here means that these sectors are all equal. So it means this central angle is equal to this central angle, and this angle. Arcs are also equal, and areas are also equal. So how many times longer is the length of arc AE compared to arc AB? So that means 4 times. So our answer here is 4 times. Okay, moving on to question number 2. When the area of sector AOD, okay, where is sector AOD? AOD. So this sector. When the area of sector AOD is 36 square centimeters, find the area of sector DOE. So sector DOE is this sector. Okay, so what is the area of sector DOE? Okay, since these sectors, these 4 sectors are equal, then the areas are also equal. So it means 36 divided by 3 sectors are inside this sector AOD. So 36 divided by 3, that's equal to 12. So each sector's area measures 12 square centimeters. So sector DOE is also 12 square centimeters. Okay, now let's answer this simple activity. We will find the value of x plus y. Okay, in these two figures, we have to find the value of x in this circle and find the value of y in this circle. Okay, let's start with this circle. Okay, this x is referring to the measure of this angle. Okay, we have here given or clues that this angle is 25 centimeters. Okay, this arc measures 7 centimeters and this is 42 centimeters. Okay, if you're going to analyze this figure, okay, this is 7 centimeters and this is 42 centimeters. How many times bigger this arc compared to this arc? So from 7 to 42, that means this arc is 6 times, okay, larger or bigger than this arc. So 7 times 6, that's equal to 42. So it means this central angle is also 6 times bigger than this central angle. So 25 times 6, then that's equal to 150. So it means x is 150 degrees. Okay, what about the measure or what about y in this figure? So y here is the measure of this arc. Okay, let's take a look at the given or our clues here. This central angle is 40 degrees. This is 120 degrees. And this arc measures 24 centimeters. Okay, take a look at these two central angles. Okay, it means this central angle that measures 120 degrees, this one is 3 times larger than this 40 degrees or this central angle because 40 times 3, that's equal to 120 degrees. So it means this arc is also 3 times larger than this arc. So how are we going to find the measure of this arc? So it means 24 divided by 3, then that's equal to 8. So this is 8 centimeters. Okay, to find the value of x plus y, okay, x is 150, so x plus y. X is 150 and y is 8, so 150 plus 8, that's equal to 158.